Ready for takeoff.
Today we're going to be carrying on with what we were talking about yesterday. Well, an extension of yesterday. And we're going to be talking about today, we're going to be talking about dependent events. Dependent events are events that happen depending on what happened the first time. Or we'll talk about it here. Dependent events the biggest issue, the biggest difference between dependent events is dependent events, we're going to talk, it's not so much with dice, it can be, but, or flipping of a coin, but dependent events, the key thing is you do not put it back. Highly important. That's the biggest issue with dependent events. We're still talking about up here when we talk about event 1 and event 2. But the biggest issue is you don't put it back. So you have to look at the events, each individual event separately. For example, okay, let's say I have my deck of cards. Now, I want to know what's the probability to draw a face card twice. Okay? Now, we talked about yesterday that there are 12 face cards in a deck of cards, and that's 52. Okay, so I have my face cards. I'm looking at my face cards. I know I have 3 in each one, and then there's 4 suites, so that's 12 out of 52, and that reduces down to 3/13. Now, so my first event is 3/13. I reach in and I'm cheating, but I draw a card, but I keep that card. So what's the probability of the second event? Okay, the second time I keep the card, I do not put it back. So now I have how many cards? I have how many face cards? 11. Remember, I kept it. How many cards are there altogether? 51. So now I multiply, I get 33 and then I get 13 times 51. 6, 6, 3, divide that, you get 11 over 221. So that's probability. What if I decide to draw, what's the probability of drawing a red card twice? So we already discussed that 1/2 of the cards are red. So that's 1/2. But I draw a red card and I keep it. Oh wow, look at that. What's the chances of that happening? And I keep that card. Okay? Well, here. We'll do this just so it doesn't confuse you from the last time. I draw the 10, but I keep it. So now I have 51. Now how many cards were red? Well, we got 26 out of 52, but now I have 25 cards are now red instead of 26, which is my initial one. So now I have 1/2 times 25 over 51 because I drew the card and I kept it. So now it's 125, so that's 25 times 102. That's my probability now. Now, let's go back and let's look at my bag of chips here. Okay? Now, I want to draw a red chip, then draw yellow. Okay? So, we know from yesterday, or from the last time we looked at these chips, I have 10 chips altogether. Oh, wait, let me dump these out again. I've got 10 chips altogether. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I had 10 chips altogether. 1 is yellow, 4 are green, 3 are yellow, and 2 are blue. Okay? So let me put all my chips back in my bag. Okay? Now, I want to know what's to draw a red chip, then yellow. So the probability of me drawing a red chip is 2 out of 10. So that translates to 1/5. So I got 1/5 times, now I reach in and I pull out a red chip. Woo! I keep it. Now what's the chances of me drawing that yellow? Well, how many chips are now left in the bag? 9. How many of them are yellow? 1. So 1/9. So it's 1 times 1 is 1. 5 times 9 is 45. So 1 out of 45. Now, what's the chances of me drawing a green chip, then red? Okay? So, I reach it. The chances of me drawing a green chip are 4 out of 10, which translates to 2/5. 2/5. I reach in. I get a green chip. I set it down. I keep it. What's the chances of me drawing a red chip? Well, there's 3 red chips left in there, but how many chips are there left in the bag? 9. So that translates to 1/3. 1/3, that's 2, and that's 15. 2/15. Okay? It's all a matter of the biggest issue between these two that you have to remember is independent, you put it back. Dependent, you do not put it back.